Here's the conclusion of the reaction rates. So here's the data in case if you didn't record it. Just to recall, when we did the first experiment with the cold water temperature was 9 degrees Celsius and the time was 1 minute and 44 seconds. This was the longest time because it was the coldest. We also did it in hot water. Temperature was 62 degrees Celsius and it was very, very rapid. It was 18 seconds. Remember, the higher the temperature, the faster the molecules are moving. So this makes sense, the time would drop. Now, the room temperature one should probably be in between 18 seconds and 1 minute and 44 seconds, and it is. So that's what is expected. And when we took the room temperature tablet and when we crushed it, so we're kind of comparing these two right here, if we crush this tablet into smaller pieces, if you notice, it dissolves about 3 times much more quickly because there's more surface to dissolve because it's been crushed into those smaller pieces. So let's take a look at the questions. Does the tablet dissolve faster in warmer water or cooler water? So the tablet dissolves faster in the warmer water. So explain why the reaction rate is faster. So it's faster in the warmer water. This is due to the molecules of water speeding faster inside of itself. And so therefore it can react with the tablet faster since they're moving faster. So the tablet dissolves faster in warmer water, and the explanation is because the molecules of water are moving faster to dissolve the tablet. The molecules of water are moving faster to dissolve the tablet. Does the tablet dissolve faster as an intact tablet or when it is crushed? It dissolves faster when crushed. Explain why the reaction rate is faster. This is because the pieces are smaller. Smaller pieces have allowed more surface to be exposed. Have allowed more surface to be exposed to the water. It dissolves faster when crushed. Smaller pieces have allowed more surface to be exposed to water. And again, the more surface that you have, the more the water is going to react with that tablet. So reaction rates are the speed of the reactions. Graph the speed of the reaction and temperature below on the XY axis. Assume that cold water is 0 degrees. Well, actually, we have temperatures of this that we'll actually do. Graph the temperatures on the x-axis with each line representing 5 degrees. Graph the reaction time on the y-axis. Each line is going to be representing 10 degrees. Okay, so here we have, actually we can probably do this a little bit more. So let's go ahead and we'll start at 0. And we'll go to 10, 20, and 30, 40, 50, 60, 70, 80, 90, and 100. So is this time or temperature? Does the temperature depend upon the time, or does the time depend upon the temperature? This is the dependent variable, and this is our time in seconds. So here's going to be our temperature scale down below here. And we'll just do these, each line is going to be representing 10 as well. 10, 20, 30, 40, 50, 60, and we didn't go above 70. So now what we're going to do is we're going to be graphing this data that we have right here. The cold water was close to 10 degrees, so it's 9 degrees, and it's 1 minute and 44 seconds. Well, if a minute is 60 seconds, 60 plus 44 would give me 104 seconds. So it's close to being right about here. So at 9 degrees, okay, 9 degrees and 104 seconds. Room temperature was 20 degrees, so we're right about here, and we're going up to 48 seconds. So almost up to 50, so it's going to look like this. Hot water at 62 was at 18 seconds. So right about there. This is interesting. This may not be a linear relationship. This could be what's called an inverse relationship. So it's looking more like that rather than a straight line. So time is over here, our temperature, we've labeled our axes, and what this is showing once again is when you increase the temperature, when it's warmer, what happens to our time? We decrease the amount of time that it takes. And if you decrease the amount of time, what's happening to the rate or the speed of the reaction? Your reaction, if you have a very short time, is increasing the speed, or it's increasing the reaction rate. And vice versa. When we decrease the temperature, lower temperatures over here, our time is increasing. If it's going slower, our speed is going slower as well. So we decrease the rate, and the speed is going to go down as well. So again, this is showing how temperature affects the reaction rate. It also shows how the size of the particle affects the reaction rate. So the higher the temperature, the faster it goes. The lower the temperature, the slower it goes. And then also when you crush it up into smaller pieces, that will increase your rate of reaction.